Okay, welcome to my channel. Today we'll be solving chemistry. So we're going to solve a number of stoichiometrical questions. So now, let us start solving our questions. Okay, question number 1 reads, the major air pollutant of coal burning power plants is a colorless, pungent gaseous compound containing only sulfur and oxygen. So the substance contains only sulfur and oxygen. Okay. Chemical analysis of 1.078 grams sample of this gas showed that it contained 0.540 grams, okay, 0.540 grams of sulfur and 0.538 grams of oxygen. 0.538 grams of oxygen. What is the empirical formula? What is the empirical formula? Okay, so for this one, we'll not waste much of time. So whenever we are calculating the empirical formula, it is so important that first we calculate the number of moles. Okay, so since we are given the masses which are here, we know that number of moles is equals to mass over the molecular mass, or the Mr. I'll be using Mr. to represent the molecular mass. So in all the questions that I'll be solving, I'll be calling this as Mr. Okay, so we are given the masses. We are given the masses here, so we'll just divide these masses by their atomic masses of these two elements. So we find that the atomic mass for sulfur is 32.06 gram per mole. For oxygen, which is 16 gram per mole. We are using 16 here because oxygen is 15.9994. When we try to round this off, you find that it will take you back to 16. So it is better you go direct to 16. Okay, so now this gram and this gram will cancel. This gram and this gram will cancel. You will remain with the number of moles. So now, what are we getting here when we calculate fast? Okay, so we're getting 0.0168 moles here. Then we come to this one, which is 0.538 divided by 16. Okay, it is giving us 0.0336. It goes. So our interest will just end there. Then from here, we are looking for the empirical formula, so we must divide these number of moles by the smallest one. So when we check, the smallest number is this one. So we'll say over 0.0168 moles over 0.0168 moles. So these moles, will cancel. These moles will cancel. Then next, we find that when we divide this one, it is just 1. Then we come to this one. Okay, so we are getting exactly a 2. So the ratio is 1 to 2. 1 to 2. Therefore, our empirical formula, so the empirical formula is S, which is 1, O, which is 2 there. So this was the empirical formula. We're done with the question number 1. Okay, so we come to question number 2. So equation number 2 says a piece of iron ore is found to contain a compound containing 72.3% iron and 27.7% oxygen with a molecular mass of 231.4 grams per mole. What is the molecular formula of the compound? Okay, so these guys are saying, so this is our second question. So I'll just draw a demarcating line here. Okay, so they're saying there was iron which was contained by 72.3%. Then we have oxygen with how many percent, which is 27.7%. Okay, so they want us to calculate the molecular formula. So molecular formula. Okay, they want the molecular formula. Now, what are we going to do? Okay, first we know that molecular formula is equal to N multiplied by the empirical formula. Okay, now looking at what we are given here, we don't have in the empirical formula, we don't have the N. Therefore, first of all, since it is possible that we can calculate the empirical formula here, then we'll calculate the empirical formula. So we're going to say we will get these as masses. So So this one will be 72.3 grams, then this one will be 27.7 grams. Now, we know from the first question, calculating the empirical formula, we divide the masses by their misters. So the relative atomic mass or relative atomic number for iron is 55.845 gram per mole. Then for oxygen, it is known 16 gram per mole. This guy and this guy will go, this guy and this guy will go. So then from there, we will start our calculations. So we divide it there. So here we are getting 1.295. It goes. So it goes. Then we come to this one, which is giving us 1.706. It goes. So just say moles. Now we divide by the smallest number. So the smallest number is 1.295 moles. 1.295 moles. So these moles will cancel, these moles will cancel. Then from there, we know that this is 1. Then here, okay, we are getting 1.3. It goes. So I'll just write 1.3 here. Okay. Now, what does this mean? This means that our empirical formula would be iron with 1, then oxygen with 1.3. Okay. Don't get confused to say, how come I'm not rounding it off? Why not? Okay. Next, we are going to, since we have known the empirical formula, we know that molecular formula is equal to N multiplied by the empirical formula. In this case, from the question, we are given the molecular formula, which is 231.4. 231.4. Then we have the empirical formula. Now, we have to calculate the empirical formula here so that we can put here so that we calculate this N that we are not seeing here. Therefore, we will make N the subject of the formula. So when we make N the subject of the formula, of course, we know that we will divide by empirical formula over empirical formula. So this and this will go, and we will remain with our N is equals to the molecular formula divided by the empirical formula. So N is equals to the molecular formula, which is 231.4 gram per mole over the empirical formula. So we have to calculate the molecular mass of this empirical formula. By the way, this is the molecular mass. So I'm just using the word molecular formula, but this is molecular mass. Worry not about that. Yes. Now, from there, what are we going to do? So let us calculate the empirical formula for formula mass for this guy. Okay. So iron plus 16 times 1.3, okay, which is, okay. So when we calculate the empirical formula for this guy, we find that it is 76.645 gram per mole. So we will get this number and bring it here, 76.645 gram per mole. So this gram per mole and this gram per mole will automatically cancel. Then N will be equal to, so what are we getting? Okay, which is 3 point whatever. So our main interest is to get this one. Yeah. Now, we have known the N. Therefore, to find the molecular formula is equal to N multiplied by the empirical formula. In this case, our molecular formula will be equal to N is 3 multiplied by the empirical formula. The empirical formula, which is this guy, 1.3 here. So our molecular formula will be equal to something of this nature. Okay, so 1.3 times 3, which is giving us 3.9. Okay, 3.9. Now, we know we cannot leave a number like this, so we'll round this off. So our molecular formula will be equal to iron 3, oxygen 4. Okay, so this is our molecular formula. Okay, so we are done with this question. So we'll demarcate. We come to another question. Now, another question is reading: an ACE chemistry student heats a piece of iron metal in a crucible. The reaction is, okay, so let me just get the reaction. plus oxygen, which is producing ion X is square. Okay, this is what have been produced. Now, they are saying we are given the table here. So let me just write something here. So, okay, how many lines are there? How many lines? 1, 2, 3, 4, 5, 6, 7. Are they 7 there? Okay, we can still count. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so put 8 here. Then I'll do this. Okay, so the first one has the mass of what? Of crucible. Okay, this is the mass of the crucible, which is 27.5 grams. Mass of crucible plus, so I'll just say crucible plus iron, which is 28.62 grams. Okay, then we have the mass of iron. So the mass of iron, which is not given, then the mass of what? Crucible. The mass of crucible plus iron oxide. So we know that our iron oxide is this guy, okay, which is 29.10 grams. Okay, then what are we given? Okay, then we are given mass of iron oxide. So iron oxide, okay, we are not given anything. Then there is moles of iron, we are not given. There is mass of oxygen, mass of oxygen, we are not given. Then moles of oxygen, we are not given. Okay, now we can able to see to say these guys wants us to complete the table, because they are saying complete the data below, determine the empirical formula of iron oxide. Okay, so we complete the table. Now coming to the table, we can see that this is 27.5 grams of the crucible. What does this mean? It means that they added the crucible plus iron, which means this one 28.62 grams to be like this. They added the mass of the crucible plus that of iron, and we know that the mass of the crucible is 27.5 grams, and the mass of the crucible plus iron is this, which means for us to find the mass of iron here, we just have to say 28.62 minus 27.5. So 28.62 minus 27.5, okay, which is giving us 1.12 grams. So 1.12 grams. We are done with this one. We come to the mass of what? Of iron oxide. Okay. Now, coming to the mass of iron oxide, they are saying when we add the crucible mass plus that of iron oxide, they give us 29.10 gram, which means for us to know the mass of iron oxide, we just have to subtract the mass of the crucible from the combination with the iron oxide. So we'll say 29.10 minus 27.5 minus 27.5, which is giving us 1.6 grams. 1.6 grams. Okay, so they want the moles of what? Moles of iron. Now, moles of iron, we know that we are given the mass here, which is 1.12 grams, divided by the mixture for iron, which is known to say it is 55.845 gram per mole. So this gram and this gram would what? Will cancel. Then we'll say the number of moles for iron is 0.02. It goes, so we just say moles. Okay, so we'll bring it here, 0.02 moles. Okay, then we come to the mass of oxygen. Now, the mass of oxygen, you don't have to waste much of time. Since you know the mass of iron and you know the mass of iron oxide, according to the law of conservation of matter, which states that the amount of a reaction or the amount of reactants is equal to the amount of products, which means if the iron reacted with oxygen to produce iron oxide, the mass of iron was combined with the mass of oxygen to give us this. Therefore, for us to know the mass of this, since we know the mass of this and this, we will just say the mass of this minus the mass of this. What will remain is the mass for oxygen. So the mass of iron oxide is 1.6 grams minus the mass for iron, which is 1.12 grams, which is giving us 0.48 grams. 0.48 grams. Okay. Now, from here, where are we heading to? So we'll write 0.48 grams. What is the next equation? Moles. Okay. So they want us to calculate the moles of what? Oxygen. Now, the moles of oxygen. The moles of oxygen will be found by mass over Mr. So the mass is this one, which is 0.48 grams over the Mr for this guy, which is what? 32 gram per mole. This guy and this guy will go. So what do we get? Okay, which is 0.015 moles. Okay, so 0.015 moles. Okay, last question, which is saying calculate the empirical formula. Okay, so for us to know the empirical formula, I think from our calculations we already have the number of moles for iron, we already have the number of moles for oxygen. So we know that we have oxygen, iron and the oxygen. The number of moles for iron is 0.02. The number of moles for oxygen is 0.015 moles. So we divide by the smallest one, which is here. So 0.015, 0.015. So we know that this one is just 1. Then the last one. Okay, so it is giving us 1.333333. It goes. Okay, so what are we going to do? Alright, iron. Then we can round this off. So when we round it off, it will give us just 1. Then this one will remain as 1. Okay, so we're done with this one. So this is the empirical formula. Okay, we proceed to another question, which is okay. What does the other question says? Silver nitrate solution is added to 25.00 milliliters of 0.500 molarity potassium chloride solution until normal precipitate forms. What mass of silver chloride will be formed? Okay, so they want us to calculate the mass of silver chloride. Okay, now it's so important that we first of all identify the equation. So silver nitrate reacted with, was added to potassium chloride to produce, okay, so to produce, that is silver chloride plus potassium nitrate, of course, like this. Okay, now from there, what are they saying? They want us to calculate the mass of silver chloride. Now we know that, so silver chloride is here. We know that number of moles is equals to mass over Mr. They want us to calculate the mass. We can calculate the Mr. What of the number of moles? Okay, now let us make mass the subject to the formula. When we manipulate this, we find that mass is equals to number of moles multiplied by the Mr. Okay, so mass is equal to, what is the number of moles? Okay, now coming to the reading instructions, they are saying silver nitrate solution is added to 25.00 of, so 25.00 milliliters of a 0.500 molarity, which means mole per liter of potassium chloride, which means we are given something for this substance here. Now let us let's look at the number of the mole ratio between potassium chloride and the silver chloride. So the mole ratio is 1 to 1. If the mole ratio is 1 to 1, it means the number of moles for potassium chloride is equal to the number of moles for silver chloride. Therefore, what are we going to do? If they are equal, then what we can do here is the same thing that we can do here. Then we know that we are given the volume. We are also given the concentration or the molarity. Therefore, we know that molarity or concentration is equal to number of moles over volume. Okay. Now, we know that since the mole ratio is 1 to 1, the number of moles that we can find here is the same as the number of moles that we find here. Therefore, we can make this the subject of the formula. So we will say we cross multiply whatever. So N will be equal to concentration being multiplied by the volume. Okay. So since the number of moles which is here is the same as the number of moles which is here, we will replace this number of moles by concentration multiplied by volume. Therefore, our equation will be concentration times volume, then times the mixture. Okay, so our mass will be the concentration, which is 0.500 mole per liter, being multiplied by the volume, which is 25.00 milliliters. So we will convert this by saying 1 liter over 1000 milliliters times the mixture. So what is the mixture for silver chloride? Okay, let's do the calculations. Silver, then chloride, chlorine. Okay, so we add, which is giving us 143.3 gram per what? Per mole. When we reach this extent, simple. We have mils here, we have mils here. We have liter here, we have liter here. We have more here, we have more there. Okay, what have you remained with? We have grams. Okay, then I'll say our mass will be equal to, let us add now. Let us do the calculations. We are not adding. Okay, first. What are we getting? Okay, which is 1.7915 grams of what? Silver chloride. So this is our mass. Is this our final answer? Okay. So we check here, which means our final answer must be 1.791 grams. Okay, this will be our final answer. Okay, another question. We are done with this one because it was just requiring us to calculate the mass. Okay, another question. Calculate the number of moles of copper sulfate contained in 100 ml of 1 molarity copper sulfate solution. Okay, so we are given 100 milliliters of 1 mole per liter of what? Copper what? Sulfate. So calculate the number of moles. Okay, so how are we calculating the number of moles? Simple. We have volume, we have molarity here, and we know that from our previous question, there is somewhere where we made any subject of formula, which is number of moles. So we just get this. So saying number of moles is equals to concentration being multiplied by the volume. We have the volume here, we have the concentration here. So we'll not waste much of time. So N is equals to 1 mole per liter multiplied by 100 milliliters being multiplied by 1 liter over 1000 milliliter. This one is just a conversion factor because we are given the volume in mils. So we have to get rid of the mils. So this guy and this guy go. We have liter here, we have liter here. So number of moles will be equal to, what do we get when we multiply here? So I can just cancel this 0 and this one. 1 times 1 divided by 10, which is 0.1 moles of what? Copper sulfate. Copper sulfate. Okay, we're done with this one. Then again, the question is further saying calculate the number of moles, the number of sulfate ions. Okay, sulfate ions. So simple. When we look at the mole ratio between, we have copper, which is made copper ions, okay, plus sulfate ions. When we bring these together, we form something like these two come here, these two we will come here, we can get rid of them since they are the same. So the ratio is just 1 to 1. So the number of moles which are here are equal to here. Good. So if the number of moles are like that, then we know that the number of moles that we calculated here are present in this substance, are also present in this substance. Okay. Now, what are we going to do? Simple. Since we have already known the number of moles for this guy as 0.1 moles, then we are converting this to number of ions. So what are we going to do? We just multiply this value by the conversion factor from moles to number of particles. And we know that since we want to get rid of this number or number of moles, we'll say 6.023 times 10 to the power 23 ions over 1 mole. So this guy and this guy go. So what are we going to have? What are we having? Okay, what number is this? 6.023 times 10 to the power 22 ions. Okay, so we are done with this one. We're done with this one. Okay, coming to another question. What volume of 0.01 molarity sodium carbonate solution is required to neutralize 25 centimeter cubed of a solution containing 0.98 grams of sulfuric acid? Okay, the equation for the reaction is sulfuric acid, which is reacting with the sodium carbonate to give us sodium sulfate plus water plus carbon dioxide. Okay, that's the equation. What volume of, okay, so they want us to calculate the volume of sodium carbonate. Where is sodium carbonate? What volume of sodium carbonate? So on sodium carbonate we have 0.01 mole per liter. Okay, mole per liter. Solution is required to neutralize 25. So we have 25 centimeter cubed of a solution containing, so the solution of these two. So we'll get this and bring it here. Okay, so 25 centimeter cubed of solution. Okay, so now what can we do with this question? Okay, so they have given us the mass of sulfuric acid, which is 0.98 grams. Okay, so we are given the volume here. We also have the molarity. Okay, simple and straightforward. So the first thing, let us calculate the number of moles for sulfuric acid. Acid. Okay, so we know that N is equals to 0.98 grams divided by the mixture for sulfuric acid, which is what? 98.07 gram per mole divided by, also these two cancels. Then what are we getting? Okay, 0.009991943 moles. Okay, so from here we have known the number of moles for what? For sulfuric acid. We have known the number of moles for sulfuric acid. But what does the question say? What volume of a 0.01 molarity sodium carbonate solution is required to neutralize? Okay, so on sodium carbonate we are given this guy. Okay, now for us to know the number of moles, what are we going to do? We will get the mole ratio between sulfuric acid and the sodium carbonate, which is 1 to 1. So the ratio is 1 to 1. What does this mean? This means that the number of moles which are present here are equal to here. So we will not waste much of time. If the number of moles for sulfuric acid is 0.0099 whatever is this, then this is the same number of moles for sodium carbonate. Then from there, what are we going to do? We want to calculate the volume. So we will say this guy, which is concentration, is equal to number of moles over the volume, and they want us to calculate the volume. So we'll say we have the number of moles, we have the volume with the concentration. So we'll make V the subject of the formula. So volume will be equal to number of moles over concentration. So volume is equal to number of moles, which is 0.009999143. Oh, there is 9 somewhere here. Okay, moles divided by the concentration, which is 0.01 mole per liter. So mole and mole, when you cancel, volume will be equal to what? What will be the volume? Let's calculate. Okay, so it will be 0.99914 liters. Okay, so our volume is equals to, we round this off, it will be 1.00 liters, which is the same as 1000 what? Milliliters, which is the same as 1000 centimeter cubed. So this is how it is. Okay, another question. Okay, so another question says, what would be the limiting reagent if 75 grams of okay, so I can see that there are 3 bromine atoms there, 2 carbons, so that is an organic compound. So I can name that compound as tribromoethane. Okay, so tribromoethane reacted with 50 grams of oxygen. So tribromoethane reacted with oxygen. Okay, so we are given the equation here, which is tribromoethane reacting with oxygen to give us what? To give us 8 carbon dioxide plus 6 H2O. Plus what? Plus 6 bromine, dibromine. Okay, or dibromine. Okay. What would be the limiting reagent? So we are looking for the limiting reagent. So we are given the mass, which is here 75 grams. Then for oxygen is what? 50 grams. Okay. Okay. So what will be the limiting reagent? So I'll do the shortcut for this one. We calculate the number of moles. So divided the misters. So the mister for this guy. Let's calculate. So 186.85 gram per mole. Next, for oxygen, we don't waste the time. That's what? 16 by 2, which is 32 gram per what? Per mole. So this guy and this guy will go. This guy and this guy will go. What are we getting when we do the divisions here? Okay, which is 0.401 mole. Then here, what are we getting? Which is 1.5625 moles. So this is the number of moles which are available. Some people will use the word present. These are present. Okay. The next thing, since I said we'll do the shortcut one, we'll just get the molar numbers. So I'll say this molar number will be divided by the number of moles. So what I mean is n over the molar number which is here 4, and this one. These two must be equal over 11. So we'll say 0.401 mole over 4 must be equal to, we don't know whether it is equal or not, must be equal to the number of moles, which is 1.5625 mole divided by 11. What are we getting? Okay, so here we are getting 0.1. What of here? What are we getting? We are getting 0.14. Okay, so we can just compare these two numbers. Which one is greater than the other? This one is bigger, or it is greater than this one. So if this is small, then it is the limiting reagent. So therefore, the limiting reagent or reactant is tribromoethane. Tribromoethane. Okay, wait for another video. For today, we just end here. So we'll continue solving stoichiometry up to a number of questions.